Questions 21 through 25 on the 2006 grade 10 Cayley math contest. If p, q, and r are positive integers, and p plus 1 over q plus 1 over r is 25 over 19, then q equals. Well, cross-multiplying is going to lead to nowhere, so I'm certainly not going to do that. I'm just going to experiment by adding certain values for r and p and seeing if we get an integer value for q. All right, so first I'll start with the most obvious, in my opinion, which is r equals 1. Let's see what happens. That gives me 1 over q plus 1. And 25 over 19 can be split into 19 over 19 plus 6 over 19, right? So that means this basically just becomes 1 plus 6 over 19. And that's p over plus 1 over q plus 1. Now let's see if this gives me integer solutions. Well, the p looks like it matches pretty well with that 1. So I'll let p equal 1, and therefore those disappear. And that just leaves me with 1 over q plus 1 is equal to 6 over 19. Cross multiply, 19 is equal to 6q plus 6. And therefore 13 is equal to 6q, and q is equal to 13 over 6. And unfortunately, q is not an integer. All right, no problem. Let's start again with a different number. But the good news is that we don't have to start all the way at the very beginning. We can just use part of what we did. We can use p equals 1, and I'll explain that right now. So we've got our equation, right? P plus 1 over q plus 1 over r. And that's 25 over 19. And just as we did before, I'll break it up into 19 over 19 plus 6 over 19. So that becomes 1 plus 6 over 19, correct? And before we had set r equal to 1, and unfortunately we didn't get an integer value for q. But I like the fact that p being set to 1 makes me eliminate that. The 1 can disappear from both sides. So I'm going to keep that. And that just leaves me with 1 over 1, q plus 1 over r is 6 over 19. So at this point, I think I can work with this. Let's cross multiply here. This gives me 6q plus 6 over r is equal to 19. Now at this point, I have to sort of plug and play with values of r to see if I can get an integer value for q. And after staring at this for a little bit, if r is equal to 6, this will work, I think. So 6q plus 6 over 6 is equal to 19. 6q would be, that's plus 1, so if you bring the 1 over, it would be 19 minus 1, which becomes 18, and there you go. Q is equal to 3. So if p is 1, r is 6, q will equal 3, and therefore number 21, the answer is C. A positive integer is called multiplicatively perfect if it is equal to the product of its proper divisors. For example, 10 is multiplicatively perfect since its proper divisors are 1, 2, and 5, and it is true that 1 times 2 times 5 equals 10. How many multiplicatively perfect integers are there between 2 and 30? The first thing I'm going to do is list all the numbers between 2 and 30. All right, here we go. Let's go through these one by one. Now, the first thing I want to do is eliminate certain ones that obviously will never work, and those are the prime numbers. And the reason is because prime numbers, as I'm sure you know, have only divisors such that they can only be divided by 1 and themselves. Now, in this definition in the question, they are not including the number itself. Did you notice that? 10, for example, they only included 1, 2, and 5. They did not include 10 as a divisor. So if you look at any prime number, its factors are only going to be 1. So for example, for 29 is a prime number, right? And 29's prime factors are 29 and 1, but they are not including the number itself. That's a little tricky, not extremely tricky, but a little tricky in the question stem. So that means instead of 29 and 1 as its divisors, I only have 1. That's it. So 1 by itself only gives me a product of 1, which obviously is not equal to 29. So I can get rid of all the prime numbers because they all face the same scenario. So let's see, the prime numbers are 3, 5, 7, 11, 13, 17, I think. Is that a prime? 19, 23, and 29. All right, so that was good. Helped us eliminate quite a few. Now let's go through this case by case. 4. Form the divisors not including the number itself are just 2 and 1. Now, when you multiply 2 and 1, does it give you 4? It does not, so cross out 4. How about 6? Its divisors are 3, 2, and 1. When you multiply those, does it equal 6? And the answer is yes, it does. So 6 is one of my multiplicatively perfect numbers. All right, let's keep going here. What's the next one here? 8, right? 8. The divisors are 4, 2, and 1. When you multiply those, do they give you 8? And the answer is yes, they do. So circle that one. So you see, you get the hang of it. And I'll just keep doing this here. For 12, the divisors are 6, 4, 3, 2, 1. If you multiply all of those, they will certainly give you a number much greater than 12. So 12 is out. I think I skipped 9 here for some reason. I don't know why I did that. All right, well, 3 and 1 are the divisors for 9, and 3 times 1 is not equal to 9, so 9 is out. 10, they actually give you in the question, right? They give you that as part of the question. That's one they sort of just handed to you for free. All right, we don't have too many more. Let's just keep going. 14, the factors are 7, 2, and 1. Do they multiply to 14? And the answer is yes, they do. And let's see, next one is 15. The factors are 5 and 3 and 1. When you multiply them, they do indeed equal 15. The next one is 16. Its factors are 8, 4, and 2. And when you multiply that, it will be much greater than 16, so 16 is out. 18 is the next guy. Factors are 9, 6, 3, and 2. When you multiply those, it's going to be much greater than 18. So 18 is out. 20. Its factors are 10, 5, 4, and 2. When you multiply all those, it's going to be greater than 20. So that's out. Next one is 21. Its factors are 7, 3, and 1. When you multiply those, you get exactly 21. So that's another one. Next one, let's see here, 22. Its factors are 11 and 2 and 1. You multiply those, you get 22. So that's one to include. 24, its factors are 12, 6, 4, 3, and 2, and 1. And obviously, when you multiply those, you get much greater than 24. 25, its factors are just 5 and 1, and that won't work. 5 times 1 is just 5. 26, its factors are 13, 2, and 1. When you multiply those, you do indeed get 26. So that's one to include. 27, its factors are 9, 3, and 1. When you multiply those, you do indeed get 27. And the last one is 28. Its factors are, let's see here, 14, 7, and 2. And when you multiply those, you get a number greater than 28. So the ones I circled are the only ones. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. So number 22, the answer is A. Quincy and Celine have to move 16 small boxes and 10 large boxes. The chart indicates the time that each person takes to move each type of box. They start moving the boxes at 9 a.m. The earliest time at which they can be finished moving all of the boxes is. So, this is all trial and error unless you have a system, which is very possible, but the system will also involve trial and error. I'm certain of it. So hopefully this won't take us too long. Celine and Quincy. So let's just start with some basic scenarios. The first one is, since Celine takes only 2 minutes to move a small box and Quincy takes a little bit longer, I'm going to give all the small boxes to Celine. Okay? And if I do that, it will take her 32 minutes, right? Each of those small boxes, 2 minutes, 16 small boxes, 16 times 2 is 32 minutes. Now, while Celine is moving these, Quincy has to be doing something. So since I've given all the small boxes to Celine, I'm going to give some of the large boxes to Quincy. So for the first 32 minutes, I'm just going to say, you move large boxes. So since it takes only 5 minutes to move one, it will take 30 minutes to move 6 large boxes, right? 6 times 5 is 30. Okay, so Quincy moves 6 large boxes, takes him 30 minutes. Celine moves all 16 small boxes, takes 32 minutes. Okay, so what is left over at this point? All the small boxes are gone, so 0 small is left over, but 4 large are still remaining. So I'm going to divide those evenly. I'll say, Celine, you move 2 of them, and Quincy, you move 2 of them. So Celine moves 2. Then the first one, it'll take her 6 minutes, so we're up to 38 minutes. And the second one, another 6 minutes, so now we're up to 44 minutes. Quincy, the first one takes 5 minutes, so we're up to 35 minutes. And the second one, up to 40 minutes. So 44. Okay. And using this system, we got to a time of 9:44. All right. Is that the earliest time? Well, I don't know. It's a candidate for earliest time. I can only cross out E. Let's keep going here. Let's see if we can get an earlier time. Now what I'm going to do is give only 15 of the small boxes to Celine and kind of work with that, because I think I can get this time closer to each other. You see what I mean by that? Like instead of 44 and 40, I want to get them closer to each other. 43, 41, 42, 40. The closer they are to each other, I think the less time it will take in terms of overall time. So 15S, and then while Celine is moving that, I'm going to make Quincy move the large boxes. So first of all, to move small boxes for Celine, it takes her 2 minutes per box. So for 15, it'll take her 30 minutes. Right? Now, while Celine is moving those small boxes, I'm going to give Quincy the task of moving the large boxes. And he takes 5 minutes for each. So in 30 minutes, he can move 6 of those large boxes. And it will exactly equal 30 minutes. And that's sort of what I want. So far we're doing great. Now, what's left over? 1 small box remains and 4 large boxes remain. Okay, first let's just deal with the large boxes. I'm going to give 2 to each. So Celine has to move 2 of them. So she takes 6 minutes, right? So 36 minutes for the first one, and then 42 minutes. We're up to 42 minutes by the time she moves the second one. For Quincy, he's going to move 2 of those large boxes. So it's 5 minutes for each. So we're up to 35 for the first one, and then we're up to 40. Now we're not done yet. We still have 1 small box. I'm going to give that to Quincy. How many minutes does it take Quincy to move 1 small box? 3 minutes. So I've got to add 3 minutes. And that's when everything is complete. Now what time are we at now? 9:43. See, I got an earlier time. And if you keep fiddling around like this, you will get to conclude that 9:43 is the earliest time. It can never be less than that. So, number 23, the answer is C. Anne and Brenda play a game which begins with a pile of N toothpicks. They alternate turns, with Anne going first. On each player's turn, she must remove 1, 3, or 4 toothpicks from the pile. The player who removes the last toothpick wins the game. For which of the following values of N does Brenda have a winning strategy? In a game, a player has a winning strategy if, regardless of what the other player does, there are moves that she can make which guarantee that she will win. So this question is going to involve casework. We're going to have to start with N equals 1. And we are going to have to keep doing that. N equals 2, N equals 3, so on. And hopefully get some sort of a pattern. And if we do, we can extrapolate that pattern and figure out which one of these numbers guarantees a win for Brenda. All right, for N equals 1, remember Anne goes first. So if Anne goes first, all she has to do is just remove 1, and she wins the game. So what I'm going to do is I'm going to write the number here that she has to remove, and in brackets I'll write how much is left over. And if 0 is left over, that means the person wins the game. Okay? And this is Anne, and this is Brenda. So we started with 1, right? N equals 1. She removes 1, and there's 0 left over, so she wins the game. So Anne wins. Now, what I'm going to do on the side here is that for every value of N, I'm going to write who won. Did Anne win or did Brenda win? So we'll just make a table on the side. So when N equals 1, it's Anne that wins. All right? So this is our system, what we're going to use. N equals 2. For N equals 2, let's say Anne chooses 1. That's the only thing she can do, because she can only remove, remember, 1, 3, or 4. Those are the only choices that she has. Those are the only choices Brenda has also. So the only thing she can do is remove 1. If she does remove 1, there's 1 remaining. Okay, that's what I'm doing in this question. I'm putting what's remaining in the brackets. If there's 1 remaining, Brenda just removes that. And there's 0 then remaining, and Brenda wins. So for N equals 2, Brenda wins. All right, so far so good. Following, nothing confusing so far, hopefully. N equals 3. Well, again, Brenda doesn't even get a chance in this scenario because Anne, is that her name? Yeah, Anne just removes 3, which she's perfectly allowed to do. There's 0 left, she wins. Boom. So Anne wins when N is equal to 3. N equals 4. The exact same story. Brenda doesn't even get a chance to play because Anne just immediately removes 4. There's 0 left, and she wins. So N equals 4. Anne wins again. N equals 5. Who wins when N equals 5? Okay, well, we just got to think about this. What Anne can do is she can remove 3. That's the strategy. Why? Because if she removes 3, there's 2 left. And when there's only 2 left, Brenda has only 1 choice, which is to remove 1. And then when she does, there'll be 1 left. It'll go back to Anne. It'll be Anne's turn again. And then since there's only 1 left, she removes it. And there's 0 left, and then she wins. So this was the strategy there. So N equals 5, Anne wins again. So see how I'm doing this? So unfortunately, this is one of those time drain questions. You got to do this for, I don't know how long this is going to go on for, but unfortunately, this is what we have to do. Unless you have a magical way of figuring this out. If you do, please, put it in the comment section. N equals 6. Well, again, Anne can use the same kind of strategy. Remove 4, meaning there's 2 left. That leaves Anne as a potential winner because Brenda can only now remove 1. When she does, there's 1 left. The turn goes back to Ann. She removes that and wins. There you go. N equals 6. Ann wins again. Now N equals 7. When N equals 7, we got a few scenarios, right? When Ann removes 4, there'll be 3 left. If there's 3 left, then Brenda can just remove those 3 and she wins. But we got to think about other scenarios too. That's just one scenario. If N equals 7 and Ann removes 3, there's 4 left. But Brenda can remove those 4 and win that way. Now what about on the first move if Ann only removed 1? If that's the case, there would be 6 left. And if there's 6 left, then Brenda is going to try to win. How does she win? Well, by removing 4. That leaves 2. And the turn goes back to Ann. She can only remove 1. That leaves 1. And then Brenda just removes that 1 to get 0. So in all scenarios for N equals 7, Brenda wins. So finally we got a check mark for Brenda. All right? I'm just going to do a couple more because I think you get the point here. You get the kind of the way of doing it here. I'm just going to do N equals 8 and N equals 9, and then we'll talk about this. Okay, so who's going to win for N equals 8? We got Ann and Brenda here. All right, well, if Ann removes 4, there's 4 left. Brenda can just remove those 4 and win. So that's the first scenario. If Ann removes only 3, there's 5 left. Then Brenda can remove 3, and that leaves 2. Then Ann can just remove 1. That's the only choice she has. That leaves 1. And Brenda removes that and wins. So it looks like so far Brenda is going to win. But Ann is smart. She's going to try to choose a strategy to make Brenda lose when N equals 8. So how does she do that? Well, she does the following. She removes only 1, and that leaves 7. And then if Brenda removes now 3, it will result in 4. So then, Ann can remove those 4 and win. So then Brenda thinks, okay, that's no good. I don't want to do that. Let me remove 4. If she removes 4, there's 3. So Ann can just remove those 3 and win. So then Brenda thinks, okay, my only hope is to only remove 1. And therefore that will leave 6. Okay, well, Brenda's still in the game here. Then it goes back to Ann. Ann says, okay, no problem. What I'll do here is I'll remove 4. I'll remove 4 from those 6. That leaves 2. Brenda can only now remove 1. There's 1. And then Ann removes that 1 to win. So Ann will play this in a way to win. You see what I mean? So therefore, for N equals 8, she wins. The only way that Ann can lose is if all the scenarios she loses. See what I mean? And that happened here when N equals 7. It also happened when N equals 2. And then one last one, N equals 9, and then we'll discuss this. Okay, so we've got 9, right? So if Ann chooses 4, removes 4, there's 5 left. Brenda is just going to say, okay, I'll just choose 3 to make 2 left. That way Ann can only remove 1. That leaves 1. Then Brenda just removes that 1 and there's 0 left. She wins. Okay. So Ann is obviously not going to use that strategy. Let's try a different strategy. She'll remove 3. 6 left. Brenda says, okay, no problem. I'll remove 4. 2 left. Ann can only now remove 1. 1 left. And Brenda removes that last one to leave 0, and she wins. All right, only one strategy left, right? And that is to only remove 1. So Ann removes 1. There's 8 left. correct? Brenda says, okay, let me remove 3. I'm not really sure here. It's 5 left. Anne removes 3, leaving 2. Brenda can only remove 1, leaving 1. And then Anne removes that 1 to leave 0, and then she wins. So this is discouraging. So Brenda thinks, oh boy, this obviously is no good. I didn't win when n equals 9. But don't worry, there is a way for Brenda to win. And it's as follows. We'll go back to this scenario. Anne starts off by choosing 1, 8 left. Brenda decides, okay, you know what, I'm only going to remove 1 this time. And if I remove only 1, there's going to be 7 left. Goes back to Anne. She's going to play a cat and mouse game. Only remove 1, 6 left. Brenda thinks, okay, I think I'm going to beat you. I'm going to remove 4. There's 2 left. Anne has only one choice to remove 1. There's 1 left. And guess what? There's 1 left. Brenda removes it. 0 left. And Brenda wins. So for 9, after all that hard work, Brenda wins. So this is basically the pattern. As you can see, you can probably do this on your own. Keep doing this. And if you do, you will get a certain pattern, right? And here's the pattern that we figured out in our trial and error system. And I put B's in below the n numbers that Brenda wins. So it was 2, 7, and 9. And in general, Brenda will have a winning strategy for n, and n minus 1, n minus 3, and n minus 4 will be the winning strategy for Anne. All right, and I'll let you do all the rest. I certainly don't think you want to hear me go through every single one. And very quickly, if you extrapolate this, you'll get a list for Brenda as follows. 2, 7, 9, 14, 16, 21, 23, 28, 30, 35, and so on. And of the answer choices, the one that is in this list is 35. So, number 24, the answer is E. A semicircle of radius 8 rocks back and forth along a line. The distance between the line on which the semicircle sits and the line above is 12 centimeters. As it rocks without slipping, the semicircle touches the line above at 2 points. When the semicircle hits the line above, it immediately rocks back in the other direction. The distance between these 2 points in millimeters is closest to. So here is a diagram that illustrates what the question stem is talking about. And you'll notice that the dotted line here is the semicircle in its original position. And then what this diagram shows is that the semicircle then is tilted so that it is now in this position. And when that happens, it hits the line above at point Q. And because of the symmetry of this diagram, when it rocks back in the other direction, it will probably hit around here. But we don't need to be concerned about that yet. We just need to figure out this distance from Q to P, and then double it, and we will get the answer to this question. So let's begin. The first thing you'll notice is that the center of the semicircle originally was right here. But when it's tilted, that center is now here, the point that is labeled O. So therefore, the distance from O to Q is the radius. And that, they tell you, is 8 centimeters. So I will put 8 right there. Now we need to figure out as many distances as possible. So the next one that you can figure out pretty quickly is O to Z, that distance right here. You know that from this point till the bottom is just the radius, and that's going to be 8. And they tell you that the line above is 12 centimeters. So that means that P all the way to the bottom is 12. So that means that this distance is 12 minus 8, which is 4. And therefore OZ will also be 4. So let's draw this triangle QZO on the side here to avoid making this diagram messy. So here is Q, here is Z, and here is O. And we figured out that that's 4. And this is, of course, just the radius, so that's 8. And this is a right angle. So now, using Pythagoras, I can figure out QZ. QZ squared is going to be, add that to 4 squared is equal to 8 squared. And therefore, QZ squared is going to be 64 minus 16, which is 48. And therefore, QZ is root 48, or 4 root 3. So that takes care of QZ. Now, we need to figure out QP, the distance from here to here. So how do we do that? Well, we have QZ. If we can figure out the distance from P to Z, then we will be able to solve this question. So QP is going to be equal to QZ minus PZ, like that. So we are now going to try to figure out the value for PZ. Well, QZ we just calculated as 4 root 3. Now I want you to concentrate on this triangle here. Notice the side lengths. If you look at the side lengths, and in particular look at the ratio, you'll notice that the ratio of the side lengths are 1, 2, and root 3. And because that is the ratio of the sides, this is a 30, 60, 90 triangle. This is 30 degrees, and this is 60 degrees, and that we already know was a right angle. Now, how does that help us? That helps us, hopefully, figure out PZ, since that is what we're trying to figure the distance of. But how does that help us? Well, look back at this original diagram, and let's fill in the 60 degrees. That 60 degrees is right here, correct? So that means this angle here is 30 degrees. Okay? Now, pay close attention. This semicircle moved from here to here. Did you notice that? It was here, and when it rotated, it went up to here. How many degrees is that? It is 30 degrees. So that means this semicircle rotates 30 degrees when it goes from this point to point Q, which is the point that touches that top line. And that 30 degrees is very important because it tells me that the distance from here to here, x to y, is essentially a fraction of the circumference of that circle. What is the fraction? 30 degrees over 360 degrees. So that is the key to the question. XY, this distance that this semicircle travels, initially it was right here at X when it was touching the base, but then once it tilts, it touches the base at Y. And we want to know what is the distance between X and Y, because X and Y are similar to P and Z. If we can figure out the distance XY, XY is the same as PZ, and that is what we want to figure out. Well, XY, as I previously mentioned, is calculated by the fact that this semicircle tilts 30 degrees. So 30 degrees divided by 360, which is the full way around, that is the fraction of the circumference that travels from x to y. All right, so the distance from x to y is 30 over 360 times the circumference of that circle. Now, 3 over 360 is 1/12. The circumference of the circle is pi times 2 times the radius. So this just becomes pi over 6 times the radius, and the radius of this circle is 8. So this looks like 4 pi over 3. All right, so that is xy, but remember xy is the same as pz. So therefore pz is equal to 4 pi over 3. So going back to this formula right here, qp is equal to qz, which is 4 root 3, minus pz, which is 4 pi over 3. And if you take out your calculator and you get an exact value in decimals, you will get 2.741 approximately. Now remember, QP is only half of the distance we are looking for, because if you go back to the question, you'll see that when this semicircle rocks back and forth, it will touch the top line at 2 points. And therefore, the other point is going to be somewhere, let's say here. And because of the symmetry of this diagram, the distance from P to that point is the same as the distance from P to Q. So since we got QP, we can just multiply QP by 2 to get the total distance. And therefore, QP multiplied by 2 is approximately 5.483 centimeters. And if you multiply by 10 to get millimeters, you get about 54.83 millimeters. And if you round that to the closest integer, it will be 55. And therefore, number 25, the answer is A.